Okay. Can anyone tell me how to do this without the calculator? See, a lot of you just using your calculator, but you can use your calculator in stage test, so I guess that's fine. But how do you do this without a calculator? What does this rational exponent actually mean? This 3/2. What's actually meaning? Okay. What does the denominator mean? The 2. What does that mean? It was 1/2. What's next one to the 1/2 power? So from an S, it's 2 words. It's a shape. SQ. SQ. Square root. Anything from the 1/2 power is a square root. This is 49 to the 1/2 power to the 3rd power. So it's really taking the square root of how many 49s? How many 49s? 3. And when we do square root, we look for pairs. Remember, the denominator is the index. Square roots, we don't have to write the index, but remember that little number in the list. Sometimes it's a cube root, sometimes it's a 4th root. That number on the index tells us our grouping. So I find pairs of 49. I don't have to go down to primes because I have a pair already. And when I find pairs of 49, what number pulls out front? So it's 149, right? Leaving square root 49. But 49 is 7 and 7, right? I'll have another pair. Whenever I pull out front, let's see, does this become 749? When I pull out 7 and 749? Be times. Anything you're putting out front is times in. It's 49 is even times in the square root. Okay? Okay, now you need your calculator. What is 7 times 49? Okay, I hope you wrote down all of that math. So the denominator of a rational exponent is the index for a root. Okay, number 2. Which expression is another way to write cube root of 125x to the 4th? What does this little 3 represent? The 3 represents denominator of a rational exponent, and if we're simplifying, it means we're going to look for a grouping of how many? 3. So first, I would probably see if I have any groupings of 3. Well, actually, maybe I should move this down a little bit. How do we simplify a square root? After tree. Okay, let's give me 2 numbers and multiply to 125. 5 and 25. Good. And we keep going into primes, right? 25 breaks down into 5 and 5. I'm sure like all the people that are writing work down. That's great. So in my cube root, I have 3 5s repeatedly being multiplied. And what else do I have? I'm not going to write x to the 4th power. I'm going to write x times x times x. I want to expand everything so I can look for groupings the size of the index. This 3 means I'm looking for a grouping of 3. So I have 3 5s. What number does that pull out as? Just 1 5. Yep. And I have 3 x's. Even though there's 4, we can only take 3 of them. And so that pulls out as what? X. And it's timesing. Cube root of what's remaining. We have an x remaining. Okay, now I'm going to look at the answers. Those are in exponential form. My simplified form here is in radical form. So this x actually has an exponent. What's the x's exponent? The first x. first power. Yep. And what's the exponent of the second x? That's x right here. What's its exponent? It's cube root. What's the exponent for a cube root? 1/3. That index is the denominator. 1/3. So if this one's 1/3, I'm going to write my 1 in a fancy form that has a common denominator. Is 3/3 the same as 1/3? Or it's, sorry, 3/3 the same as 1? Yeah. So if I have my common denominators, when dealing with these exponents and the base is the same, they're both x's. When we multiply exponents, we do what? Add, multiply, add, multiply, add. So I go 3/3 plus 1/3 is 4/3. So I'm out of room, but I'll put it up here. 5x to the 4/3. Does that match any of our answers? B. Unfortunately, today's test won't be multiple choice. So it will be up to you to do the steps properly to come up with 5x to the 4/3. That index is the denominator for a rational. Rational means fraction exponent. Okay, try number 3 by yourself, please. If x and y are real numbers, what is the simplified radical form? Notice it starts in exponential form. They're going to switch to radical form and make sure it's simplified. Okay, there's different approaches to this problem. I think some take longer, and then there's a quick way. I don't think we really found the quick way. The long one's going to get you to the right answer. It just takes a little longer. In my opinion, the quick way would be change the 1/5 first. What does the 1/5 exponent represent? Okay, it's fractional exponent. Look at the denominator. What does that 5 represent? Oh. What? What does the 5 represent? We just did 2 problems like this. So there's not a square root, it's a 5th root. And then I expand. How many x's are there? How many y's? What is the 5th root? What does that mean? Roots of 5, and that only happens for the y's. So I pull out the y, and I still have 5th root of x squared. Oh, I think that's one of our answers. Okay. Okay, we're going to skip over and look at number 8. Which expression represents the quotient? Quotient is the answer to what type of problem? Division. It even shows you a fraction there with a division bar. Okay? A quotient. Notice all the answers are not fractions. How do we know those fractions? We just go like this? Because those match? No. You can only cancel if there's multiplication to the neighbors. Right now we have a plus. So we can't cancel. And that wouldn't even match any of the answers. How can I simplify this fraction? How? Well, these aren't like terms, so that's x to the 6th and this is x to the 4th. and z to the fourth x z squared. They're not quite like terms. I don't think that would get rid of the denominator though. Math teacher's favorite F word. Factor. And the numerators are not like terms, but they do have things in common. What's the greatest common factor of two terms in a numerator? What's the greatest common factor for the 8 and the 4? 4. 4 divides into both, right? At most, how many x's can both of them give? X to the 6, x to the 4th. At most, they can give 4. At most, how many z's can both of them give? 2. Now, what we do, remember that doesn't just go away, we write it down as times, because we're moving it out, and by factoring, what we're actually doing is dividing. So we need to divide each of these pieces by their corresponding part. 8 divided by the 4 was 2. X to the 6, we're removing 4 x's to the x squared. Z to the 4th, we're removing 2 z's. It's not just 2, it's z squared. Plus 4 x to the 4th is z squared. Divide by 4, take off 4 x's, take off 2 z's. What are we left with? 1. Because if we divide 4x to the 4th z squared by itself, then this becomes 0, becomes 1. Anything divided by itself is 1. And then we have this denominator. Okay? Now we have neighbors that are being multiplied. We're actually allowed to simplify as long as neighbors are being multiplied. Okay? So we can simplify between our greatest common factor and our denominator. 4 divided by 4 equals to 1. The x's, let's have x to the 4th, divide by x squared. So I take off 2 there, I take off 2 here, and it becomes a squared. How many of these can I take off? 1. I take off 1 here, I take off 1 here, which becomes a z. So I'm left with x squared z times 2x squared z squared plus 1. It doesn't quite match my answers, so what can I do to make it match? I can distribute it back. Okay? In sign language, this is an A, this is a B, this is a C, this is a D. So distribute it and then show me which answer you get. A, B, C, D. A, B, C, or D. Distribute and which answer do you get? A, B, C, D. A, B, C, D. Which answer are you getting? Good. You see lots of A's. That's excellent. Even if you just do the first step, it matches. The only one that matches. We get 2x to the 4, because remember you add x to it, so you're multiplying z cubed. The only one with that is A. Plus x squared z. So A. Really quickly, towards further in, which problem is it? Let's remember some formulas. Ooh, on 15. This is with a hit for 15. 2 things we know about imaginary i's. What does I squared equal? -1. And what's the square root of a -1? That will help you. And also, for this quadratics, I guess we can put a number 45. And number 45, some notes about quadratics. How do you find a vertex or a maximum or minimum point on a graph? If it's in standard form, such as A, you find first the axis of symmetry, which is x equals the beginning and the end of the quadratic formula. A and B all over 2A. Once you know the axis of symmetry, you plug in your x, and that will give you your y. That's how you find a vertex, if it's in standard form. If it's in vertex form, there's a reason we call this vertex form. Oops. Because you can see the vertex in the equation. Where's the vertex in this equation? Yeah, and here, isn't that horizontal shift and a vertical shift, and what's our saying? Opposite, same. Okay, this problem right now is a quadratic. It doesn't actually use what I just wrote, that stuff. What it talks about is the roots. How do you know the different types of roots you have from a quadratic? What's the quadratic formula? Negative b plus or minus square root b squared minus 4ac all over 2a. Remember that. Just oh crap. This, remember, if it's greater than 0, you have 2 real. Less than 0, you have 2 imaginary. And equal to 0, you have 1 real solution. There's homework. It's on my website. In case you run too fast. It's multiples of 3, except for there are a couple that I changed. Website's working, hopefully. Oh, come on, wrong one. Multiples of 3, except for a couple of them were applicable. So I said multiples of 3, except for these ones, to number 20, 25, 26, and 32 instead. It's due with the same test on Tuesday, on Wednesday. So multiples of 3 to number 54. Except for, throw out these 4, 21, 24, 27, 30, throw those out, and do these 4 instead. Okay, you can always just go to my website and look at that. Stage test. Please have your homework done before stage test. Get your progress report signed. Have a good lunch. Aaron, do you need me? Okay, go back in the past inside so I can see it again. Thanks. Yeah.